Hi guys, this is Unit 2's 4.1, Module 4.1, Identifying and Graphing Sequences. The essential question, what is a sequence, and how are sequences and functions related? The simplest answer to state is that a sequence is a list of numbers in a specific order. So technically your very first example is there are certain things in this natural world that have an order to them. So, for example, 1, 3, 5, 7. And as you can see, there is a common difference or a pattern. You had 1 of something, and it goes by 2. So it went up by 2. So 1 plus 2, 3. 3 plus 2, 5. And what you're seeing here is a sequence, okay, which has a certain pattern. In this case, our common difference is just 2. Okay, and we'll get to that eventually. So understanding sequences. So this is the first official example. So a go-kart racing track charges $5 for a go-kart, almost said yogurt, a go-kart license, and $2 for each lap. Okay, so in 8th grade we talked about slope or rate of change. Well, in this situation with sequences, this is actually our common difference. Okay, the $2. Now you list the charges for 1 lap, 2 laps, 3 laps, and so on. All right. And now you get this list. So originally, if you were to drive, you would have $5 for your license plus $2 for your first lap. So your first lap is going to get you, it's going to cost you $7. Second lap, $9. Third lap, 11, and 13, and so on. This is our sequence. Now, if you notice, just like a previous informal example, we're going up by 2's. Okay, so that's something to notice right away. Now, a sequence. This is the definition of a sequence. So a sequence is a list of numbers in a specific order. Each element in a sequence is called a term. And those are the two important things to understand fundamentally about this conversation. So our first term was 7, okay? In function notation, we would say f of 1 would equal 7. And if you notice the table here, we keep on going, and basically this is our nth terms right here. So our first term, we get 7. Our second term, we get 9. Our third term, we get 11. Again, I'm looking at the sequence right here. And our fourth term gives us 13. And our fifth term, if you remember the common difference discussion, 13 plus 2, 15. And that makes sense because if you double check, 15 plus 2 will get us 17 for our sixth term. Again, noticing domain and range. Domain is really what we plug in. So our n terms is our domain. Okay. So what number is what term are we talking about? That's domain. And then the number that we actually get is the range. Okay. Now in context, domain is the laps that we take. Okay. And range is the money. Money. All right. Now, with function notation, we're going to go ahead and complete this. So again, f of 1 equals 7. F of 3 is 11. So again, our third lap gives us 11. Our sixth lap gives us 17. What gives us our 13th or $13? That would be 4 laps. What gives us $15? 5 laps. Now, the domain, identify the domain of the function. So our domain is really first lap, second lap, third lap, fourth lap, fifth lap, and the sixth lap. Seems like we top off at 6. And you can even double check by the table. All right, our range is our money. So for 1 lap, it costs 7. For 2 laps, it costs 9. Third lap, 11. Fourth lap, 13. And fifth lap, 15. And last but not least, our sixth lap gives us $17. Okay. All right, generating sequences using the explicit rule. So there's two types of rules to talk about when we talk about sequences. And the first one that I want to get to is going to be the explicit rule. So an explicit rule for a sequence defines the nth term as a function for n for any whole number n greater than 0. So basically, this is the first explicit rule that you see. And if you notice, it's just a function. Okay, functions can be used for these rules. All right, so we're going to go ahead and make a table and substitute the values for n equaling some numbers. So let's say n, we're going to use 1, 2, 3, and 4. Why? Because we want to know our first 4 terms. Okay, so for our first term, we're going to plug it into the actual explicit rule known as f of n, okay, which equals 3n squared plus 1. We're going to go ahead and substitute, just like when we did graphing or understanding functions. 1 squared is the same as saying 1 times 1, which is 1. And 3 times 1 is just 3. And 3 plus 1 gives us 4. So f of n will equal 4. If you do the same thing for our second term, we're going to have 2 squared, which is 4. And 3 times 4 is 12. And 12 plus 1 will give us 13. So f of n will equal 13. Third term, 3 squared is 9. 9 times 3 is 27. And 27 plus 1 is 28. So f of n equals 28. Or f of 3, I'm sorry, equals 28. Now, for last but not least, our fourth term, we have 4 squared, that's 16. 16 times 3 is 48. And 48 plus 1 gives us 49. So f of 4 equals 49. So that's just an example of the rule here. Notice how the common difference isn't quite as it seems, right? There's no straight common difference, right? So that's something to notice. But the first 4 terms for our guy is, or our sequence, is 4, 13, 28. Oop, there's my pen. I was wondering when that was going to happen. There we go. 28, and last but not least, 49. There we go. Okay, so your turn number 1. Write the first 4 terms of the sequence defined by this explicit rule. So go ahead and create your table. All right, so your first 4 terms. So your first term, second term, third term, fourth term for your sequence represented by f of n equals n squared minus 5. So go ahead and create your table, find your outputs, okay, or your range. And that will be your answer, these 4 outcomes. Okay, those will be your first 4 terms. Go ahead and do the same thing with your term number 2. Notice the equation is linear, and you will actually have a common difference of 4. So that is something to note right there. If you remember slope-intercept, which was y equals mx plus b, in this situation, your difference is the same as your slope, okay? All right, so generating sequences using recursive rule. Now, I showed you explicit, now I'm going to show you recursive. So recursive is, well, I like to think of it as the more redundant version of the rules. Okay, so recursive rule for the sequence defines the nth term by relating it to one or more previous terms. So basically, you have to know who's the last guy we dealt with. Okay, it's not like you can predict so far ahead. You have to go like, well, who was the last guy that came in? All right. In this situation, we're given f of 1 is 4. That means that's our first term, 4. Okay. Now, f of n minus 1 really just means the last term that we had. In this case, all right, is 4. Okay. So, so this is the recursive rule. Oops, sorry. It's including the plus 10. Let me go ahead and just highlight it. This is whole thing right here, and it doesn't show well on the screen, does it? There you go. Yellow for the win. F of 1 equals 4. That's our first term. Comma, f of n equals the last term plus 10. So for each whole number that is n is greater than 1. Why? Because there's no such thing as a 0 term. There's no such thing as a 1.5 terms. It's just got to be greater than 1 because we have to know our first term, and then all we care about from then on is the third or the second or the fourth or the fifth. Okay. Now, let's see. So again, the previous term is represented by this guy. Okay, f of n minus 1. That's all it's saying. So in this example, our first guy was 4, right? Well, what's 4 plus 10? Because that's our rule, right? 4 plus 10 is 14. But now, well, who was the last guy? 14. So what's 14 plus 10? 24. And as you can see, just keep adding 10, and we got our sequence represented by this recursive rule. So just remember, f of n minus 1 is just an algebraic way of expressing the last term that we dealt with. So we have to know where we start with. We have to know first term, okay, that actually has to be stated, and then the rule, okay? Now, what's our common difference from 4 to 14? It's 10. Common difference from here? It's 10. It's 10 all the way across. So our difference is actually the number that's either being added or subtracted right here, okay? So example 4, write the first 4 terms of the sequence defined by the recursive rule. So first things first, literally the first thing, the first term is 2, okay? So that's the first guy in our sequence. Now notice the difference here from our last guy. Our last guy was 2, okay? Our common difference here is 3, okay? So we're going up by 3. And again, we only care about the numbers greater than 1 because we already were given 1, all right, our first guy. All right, so let's go ahead and plug it in. We had 2. What's 2 plus 3? Oh, it's 5. What's 5 plus 3? 8. What's 8 plus 3? 11. So as you can see, we just keep on going with that rule. And if you notice, they're actually just plugging in function notation. Our first guy, which was, again, 1 plus 3, and that gave us 5. Next thing we had was, what was our last guy that we dealt with? Oh, it was our second term, which was, again, 5. So 5 plus 3, 8. Our last guy, f of 3, was 8, and 8 plus 3. So basically it was just like what I did over here in that area, okay? Now, again, it looks like our difference here was 3. So let me make sure I draw this a little bit better. I feel like I already did, but I kind of want to be thorough here. So again, f of 1 equals 2. 2 plus 3 gave us 5. F of 2 was 5. Okay, that's what that means. So again, just the notations. That's what they're talking about. All right. Your turn number 3. So first things first, where do we start? What's our first term? Okay, that'll be in here. And then remember, this is just the last guy that we had, plus 5. So this is our difference, okay, the last term that we had. Find the first 4, use the table, and then make sure you list your sequence, okay, which is going to be your f of n's for the first four terms. All right, constructing and graphing sequences. So if you haven't realized by now, sequences are functions in a manner of speaking. So we were talking about the go-karts, right? And it was $5 for a license and $2 for each lap. We used the explicit rule, okay? So we had a common difference of $2, and we started off with our license, okay? That was our initial cost, if you will. Now, if we used a table, first it would cost us 7, but for 2 laps it would cost us 9, cost us 11, 13, and so forth. And the ordered pairs for this set would be written like this, okay? So again, if you notice our common difference going up by 2's, that's because our common difference is 2. So we're going to plot these ordered pairs. For 1 lap, costs us $7. For 2 laps, costs us $9. 3 laps, 11, and 4 laps, it'll cost us 13. Notice how we aren't connecting them. This is not continuous. Okay, this is a discrete graph. Okay, it's discrete because again, nobody can drive 1.33 laps or 1.334 laps. It's either 1 lap or no laps. Okay, so 1, 2, 3, 4, 5. Sure, we're going around and around, right? So this is just graphing. So again, we're not connected because this is a discrete relationship. Your turn number 4. So a movie rental club charges $20 a month, plus a $5 membership fee. They go ahead and give us the explicit rule like thus, and now they want us to complete the table. So again, we're going to have to figure this out. What was our formula? What was our explicit rule? 20 times n plus 5. Okay, we get that. F of 1 is really just what? 20 times 1 plus 5, which is, well, 20 times 1 is 20. 20 plus 5 is 25. So f of n will be 25. So I'll have 1 comma 25. So 1 comma 25 is up around here somewhere. Notice how the units here go up by 20s on this graph, so be aware of that. Go ahead, finish the table. So f of 2, okay, notice the pattern, and just go ahead and start completing the graph based upon the table. Now your ordered pairs, my first one that I got was 1 comma 25, and you're going to have 5 more, okay? And then you're going to graph it over here on the graph. All right, your turn number 5, construct and graph the sequence described. So it's just very similar to the last one. The only difference is, well, there's no table. So you should probably create a table. All right. And look at your domain. We have 1, 2, 3, 4, 5, 6. So if you were to create a table, which is totally understandable, it'll keep you organized. You want to make sure you include the list of n terms along with your explicit rule. And then whatever you get out there will be your f of n's, your outputs. Okay, so go ahead and try that. And then also find your common difference, all right? All right, guys, have a great day and take care.